All right. Problem solving, especially in word problems, has been a big challenge for kids that are taking the North Carolina standardized testings. I've developed a strategy, and thankfully I was able to gain some insight from another YouTube video that I watched, just like the one you're watching right now. And I used their Buck steps and added to it. Buck is a very great technique for dissecting word problems. And dissecting word problems is when a student is using their knowledge to pull the word problems apart and really find the relevant pieces that can guide you to answering the question. When you are presented with a word problem, after you've read it completely through, box the question. Okay? Questions begin with what, how, who, how much, how many more. That's kind of how questions begin. U says underline important names and numbers. You have some word problems that only have names, or within the question want you to identify who instead of what or how many. But most commonly, the underlying pieces will be numbers, constants that are in the word problem. You circle the operations vocab. Folks, in every word problem, there are word or word phrases that indicate what operation to use, whether you add, subtract, multiply, and divide. And I listed some examples on this paper. When we see the words how many together, it means to add. How much means to add. Each is a singular term, which indicates normally one of something, but depending on the context of the problem, it can cause you to multiply or divide. Of means to multiply. Total is addition. Difference is subtraction. Factor, multiplication. Per is normally division, but it just depends on the context. And then K stands for cross out the unnecessary stuff. The stuff that you don't need. Prepositions, prepositional phrases, linking verbs, things like that. You don't really need them to solve the problem, so you can cross that stuff out. But immediately after you employ these steps, a lot of kids break down right there. They don't know what else to do. You should use what you've underlined and circled and the context of the word problem to draw a picture. Now, this picture might not be an illustration out of a book. It may be require you to make a list or draw a chart or some kind of visual that connects with what the word problem is trying to show us. You then use everything you underline and the words, the operational vocab that you circle to begin the computation. What am I multiplying? What am I adding? What am I dividing? What am I subtracting? When you arrive at your answer, check to see if your answer answers that question you put a box around. Because a lot of times we can come up with the answer and then realize we're not done with the computation. There's something else to do. And we'll explore multi-step word problems in a minute. But just take time to pause the video or copy these down just in case, screenshot it, do whatever you got to do to remember these steps. So now we're going to use these steps to solve a few word problems. I'm going to slide this to the side. Now I'm going to put some word problems up here. These are multi-step equations that I am using for my 4th graders. Okay? And we're going to use these buck steps to buck it. Put that back on here. Okay? Let me grab something to use to buck. Okay? You can take the time to write the problem down as you're waiting on me. Now, let's read it all the way through. Pay no attention to this one down here, just this one. A chef bought 7 cartons on Monday. She bought 3 more cartons of eggs on Tuesday. Each carton contained 12 eggs. How many eggs did the chef buy on Monday? Say we were going to buck this. The first step in buck says to box the question. How many eggs did the chef buy on Monday is the question. So let's box it. That furthermore lets us know that whatever answer we come up with, it should satisfy what that question is asking us to discover. U says to underline the important names and numbers. I don't really see any names, okay? Chef is the noun, but there's no reason to underline it. It has no bearing on the answer because it didn't ask who, it asked how many. So our answer should be numeric. Let's underline 7 cartons and take it sentence by sentence. Let's underline 3 cartons and let's underline 12 eggs. Those numbers should have some significance when we go to start computing. Let's see what operational vocab we can circle. A chef bought 7 cartons on Monday. Nothing up there. She bought 3 more cartons of eggs on Tuesday. The word more signifies addition. Okay. Each carton contained 12 eggs. Each can be multiplication or division. Just depends on the operations that's around it. How many eggs did the chef buy on Monday and Tuesday? How many, of course, is add. Okay? So this is a multi-step. So we're going to do a combination of operations. So let's move this word problem over here. After we've done these steps, after the C step, we can cross some of this stuff out. Moving too fast. Move some of this stuff out. As you can see, I'm crossing out all the stuff that I probably don't need anymore. Okay? After that, I should try to draw a picture. And this picture may not be an illustration from a book, but it kind of helps connect the terminology. Connect my thinking with the terminology. Okay? It says draw a picture. I know I'm talking about cartons. I can't draw really good, so I know a carton has 12 eggs in it. So I'm going to draw a carton with 12 eggs. Okay? And this is 1 carton. Okay? A chef bought 7 cartons on Monday. So he bought 7 of these on Monday. And notice I'm just illustrating the information from my problem. He bought 7 of them. So that's, if it's 12 eggs in 1 carton, the chef bought 7 cartons on Monday. Okay? He bought 3 more cartons of eggs on Tuesday. So on Tuesday, I'm going to draw another carton. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We know there's 12 eggs in a carton. But on Tuesday, he bought 3 more cartons. And we know total, he has 10 cartons. He bought 7 on Monday, 3 on Tuesday. So now we are just illustrating what our problem has told us. Okay? Each carton contained 12 eggs. Well, we have interpreted each to mean multiplication in this case. And it makes sense because when I look at the operations that I've circled, I have addition, multiplication, division, and addition. What operations relate to one another? I know some of you wanted to say multiplication and division. They're inverses. They're opposites. We define multiplication as repeated addition. So it looks like these are going to be the dominant operations. When I do 12 times 7, I get 84. So he got 84 eggs on Monday. 12 times 3 is 36. He got 34 eggs on Tuesday. Our question says, always go back to that box question, because after we draw our picture or made our list or whatever we're going to do, we use the underline and circle pieces to start the computation, which we did. We underlined 12, we underlined 7, we underlined 3. We use Monday and Tuesday to identify how many eggs he brought on each day. And the last step says check to see if your answer answers the question. Well, when I get down here to my question, it says how many eggs did the chef buy on Monday and Tuesday? Well, how many tells me to add, so I need to add his purchases on Monday and Tuesday, and that's 84 plus 36, and I should get 120 eggs, and that gives me a cumulative amount. So how many eggs did the chef buy on Monday and Tuesday? He bought 84 on Monday, 36 on Tuesday. When I add those together, I get 120 eggs in all. So that's how we solve that problem. Okay? You need time to copy that down, pause it. Okay, let's do one more. Using those same steps. Okay? Tom is reading a book with 330 pages, and he reads 15 pages a day. He has been reading for 9 days. How many pages does Tom have to read? If I was using the buck method, I would box the question first. Starts with how many. I'm going to underline the important information. Well, there's really no names. Tom is the only one mentioned, so I'll just start with the numbers. 330 pages, 15 pages, 9 days. Okay? Circle the operations vocab. Tom is reading a book with 330 pages, and he reads 15 pages a day. Really not anything in there to circle. He has been reading for 9 days. That can mean multiply. How many more? This is in the same circle. How many more is subtraction. Does Tom have to read? A signifies division or multiplication because it's a singular term. Look at the letter A, which is an article in English, like the word each. Because this, you could replace the letter A with the word each. 15 pages each day. So it kind of lets you know you're going to be multiplying or dividing. And then cross out the stuff you don't need. Now, move this over here. Do exactly what I've done the last problem. Can we draw this? He's reading a book with 330 pages. Now, I'm not going to draw the book, and I'm not going to draw the book with all them doggone pages. But I know that my underlined pieces are telling me about pages and days. So it looks like I'm up to day 9 as far as my pages go. But I won't read any more than 330 pages. So 330 pages is the most I'll read. So I'll create a bar model. It tells me that I'm reading 15 pages a day. I'm on day 9. So if I draw some little bars up under here, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm reading 15 pages each day. Now, I need to add these to see how much of the 330 pages I've already read. 15 and 15 is 30. 30 plus 15 is 45. 45 plus 15 is 60. 60 plus 15 is 75. 75 plus 15 is 90. 90 plus 15 is 105. 105 plus 15 is 120. 120 plus 15 is 135. It wants to know how many more pages does Tom have to read. Well, we've already read 135 pages. How many more do we need to read to get up to 330? What does it sound like we need to do? Well, I go back to my circled operation terms, and I know I circled the letter A, which means to multiply, divide. I circled 4, which means to multiply, and I circled how many more? Well, multiplying and repeatedly adding is the same thing. So when you witness me adding 15 over and over, that was me multiplying. It's the same as doing 15 times 9. I got 135. I'm left with my last operation that tells me or asks me how many more pages does Tom have to read. What does how many more indicate? Subtraction. I'll take 330 and subtract 135. I can't do 0 minus 5. I have to borrow from this 3 and make that a 2. This 0 becomes a 10. 10 minus 5 is 5. 2 minus 3 I can't do. I have to borrow from this 3 and make it a 2. That becomes a 12. 12 minus 3 is 9. 2 minus 1 is 1. So he's